Hello guys, in this video I will discuss my usage of OpenMediaVault, shortened to OMV. OpenMediaVault is a piece of software that turns a computer into a NAS. A NAS is a network attached storage, and to describe this, it's like a USB flash drive or external hard drive. The main benefit being that it can be accessed wirelessly on a local network, such as a home network. The reason I wanted to do this project is because it would be a cool and unique way to store files at home, while also being accessible to many family members with account access. This means they could copy files from their own computer to the NAS with a file manager like File Explorer, and worry less about their own personal backups. I was very hyped up about the Raspberry Pi 5 when it came out in late 2023. I read about projects and what it can be used for. I like computers, gadgets, and found the Raspberry Pi 5 cool as a small form factor computer that you can take around, plug in, and have desktop level power, albeit on a low end. I wanted to make something new with a computer that I hadn't done before. Currently I don't have a use for it, but I will discuss the pros, cons, and features regarding it and the OMV software I installed on it for a project in August 2024. I saw on computing websites some projects for a Raspberry Pi 5. One that seemed simple and caught my attention was making a NAS with Raspberry Pi 5. It was a bit expensive to gather the parts for a souped up hard drive, but the computer itself could be used for other things which I'll describe later on. The Raspberry Pi 5 itself with 8GB of RAM cost £64. The active cooler cost £3.45, very nice piece of hardware by the way. The 27-watt power supply cost £8.90, and I bought the Pimoroni NVMe based Duo for expandable storage, which was £18.75. To see on a monitor the commands, I needed a micro HDMI to HDMI cable, which I didn't have, costing £4. I bought a 2TB WD Black SN770 SSD for £117 because I thought I would store a lot of files on it. I will say it is listed as not ideal on the Pimoroni website for the NVMe based Duo that I must have not realized at the time, so you should go for a suitable SSD. You need some sort of storage for the NAS, separate from the operating system storage. You need a micro SD card for the operating system and other things like a monitor, power, internet access for guides. These parts cost me £216, but I was happy to invest in some computer gear. I used this guide with some help from my family to get my NAS working, a guide from Smart Home Circle by Amroot. I will give a short tutorial before describing how OMV was like for me. First, you need to get the micro SD card for the operating system and use imaging software such as Raspberry Pi Imager. You might need a micro SD card reader to connect it to your computer. I believe the Raspberry Pi OS 64-bit Lite edition is needed, as OMV does not have a GUI on the target computer, and the GUI is accessible from the web admin interface. Once the OS is flashed onto the micro SD card, it can be inserted into the Pi. Be sure to connect the storage drive to the Pi. I'm sure you can use an external USB drive with this project, but I thought a storage hat or NVMe base would produce faster results, being connected by PCIe. That may not be the case. You need to enable SSH access in the Raspberry Pi Imager so that you can input the commands to the Pi running OMV. When you turn the Pi on, connect to it wirelessly using SSH software such as Terminus or PuTTY. Input the commands written in the tutorial, especially the wget command, using the -n parameter when installing. This is because installing OMV changes the network configuration of the Pi, and I couldn't connect to it after installing the software multiple times using other tutorials. This tutorial allowed me to successfully put OMV on the Raspberry Pi. Don't restart the Raspberry Pi after installing the software. The cool thing about OpenMediaVault is the web interface, where you can access details and manage the NAS from your browser. You can input the IP address of the Raspberry Pi. You'll need software to find the IP address of the Pi, such as Network Analyzer on Android. You can also put the hostname of the device, such as http hostname.local. This brings you to the login page where you can input the username and password. By default, this is admin and OpenMediaVault, but you should change this for security reasons. You can set up the external storage in the Storage tab, select a disk, and add a file system to it so it can be read by the software. Then add shared folders. These will let you change if they can be read or written to, and if they are read-only. It also lets you set permissions for the admin and certain users. After that, you can create users and change permissions of a folder to give them access to it. This was quite helpful for me in learning basic administration, and it was simple to understand after having a go at it. I turned the SMB protocol on, which probably made it easier to share and discover files between network computers such as this NAS and laptops around the house. It's not recommended to use NAS software when outside of the home network, I suppose because of the increased security risk. Experienced users may use a VPN or other tools, but I have no idea how to configure that. And of course, there are enterprise cloud storage solutions such as Dropbox and Google Drive that function like this but are only online. I will point out that you can use the NAS wirelessly on the home network or wired using an Ethernet cable. On Windows, you would need to map a network drive in File Explorer to access the NAS folders from within Windows computers. You can also do this for macOS. I forgot if you need to share the address of one folder or the root folder, but I believe the user can see all root folders. If they have permissions, they can access their designated folders and read and write to them. This is useful for giving users a personal folder, but preventing them from altering content in another user's folder. A NAS is a very versatile device, and the dashboard has cool stats like CPU and RAM usage, disk temperatures, and available services. On the NAS, I stored some photos, and so did another family member. I regularly updated the OMV software to get performance improvements and bug fixes to different software features. It was nice to see my little machine working and that I could transfer files to it. I turned on the SMART protocol to report drive reliability. However, let me bring you to the downsides in my case. I eventually stopped this project after a few months as nobody was really using the device. It was configured for multiple users, but they didn't have a need to store files on this device. I also offered my friends the opportunity to back up their data, but they did not need to. That's fair enough. But a worse issue was experienced on my end. The file transfer speeds were extremely slow and not practical to back anything up. I had around 30 gigabytes of data such as documents and photos that I needed to back up to the NAS. The pain point was that it would take hours to back them all up. Even though the computer was new and the storage drive could handle hundreds of megabytes per second, I could not actually figure out why the transfer speed was slow between my PC and the Raspberry Pi NAS. I tried using Wi-Fi and using an Ethernet cable. The speeds ranged from 7 megabytes per second to the occasional 50 megabytes per second, but it flatlined often. And because my Wi-Fi is unreliable, if the connection stopped midway through a transfer, there was no way to resume it on the NAS, because the NAS had no graphics user interface to tell it to reconnect to a Wi-Fi network. I was using it headless without a monitor, and on the same note, the web panel cannot be accessed on another device because the NAS is not broadcasting the information. This actually happened once, so I had to cancel maybe 14 gigabytes of data and restart the process, which would take hours more. One person on the forums even told me not to use Wi-Fi when using a NAS, but that's not helpful. I understand that Wi-Fi can be unreliable, but it's easier for the user experience to do tasks over Wi-Fi rather than plugging in cables. A lot of selling points for products is that they're Wi-Fi enabled, and it's literally called a NAS. This means network attached storage, which doesn't exclude wired or wireless networks. And I think a NAS is more useful if you can use it over Wi-Fi than just with a cable. But maybe there was an issue with my usage, as I turned the NAS off to save electricity from time to time and didn't feel like I needed to plug it into the router. Earlier in the video, I mentioned that the drive WD Black SN770 may not be suitable with the NVMe-based Duo, which could be the case, but I didn't realize this at the time. Additionally, the reading and writing of files from NTFS on Windows to ext4 on Linux could have been a bottleneck. Also, the CPU is a Broadcom 2712, and while it is 8 cores at 2.4 GHz in speed, it uses the ARM architecture, which processes things differently than x86, which desktop computers use. I will make another point about ARM later. So, in the end, it was not worth it to continue using the NAS, and in reality, it was not practical for me with the slow transfer speed and lack of users. I did learn a lot about this software and it was fun to use for a bit, but the issues were not worth living with. It would be much better and simpler in most cases to get a fast external drive, and in the future I will be looking to buy a fast external SSD for backing up my data, which I would recommend to most people. If you do want to buy a NAS for things like file sharing and storage backups, you could buy one such as a Synology NAS. Now I have yet to use the Raspberry Pi for another project. There aren't many other interesting or straightforward projects I have found where I can install a software and let the computer do its thing. I was also thinking about Boink, which is a software to contribute computing power for scientific research. I have used it before on a VPS server and may make a video on it. It crashed on the Raspberry Pi after I installed a new desktop OS on it, because Boink doesn't work on ARM. This architecture is different than x86, and most desktop applications and software work on the x86 64-bit architecture. Android runs on ARM processors, but for desktop stuff ARM isn't great. It is getting more apps and software support, along with Apple, who are using ARM CPUs in their Mac computers for low power consumption and fast performance. But traditionally, x86 CPUs were better at multitasking and still have the most software support for consumer desktop usage. So even though Raspberry Pi is Linux, Linux can also be on ARM and x86, and it doesn't have the most attractive or useful apps available on ARM. I have done coding before, but I don't really like it. I can learn more in the future, but I find it difficult to code things. Compounded when on Linux, you need to use bash code to make software and things work. It's not good for the user experience and is complicated for me. So I'm not going to do intermediate or advanced Raspberry Pi projects right now. The Raspberry Pi is at home and awaiting its next project. Feel free to leave suggestions for me. I hope you found this video useful or interesting. Thanks for watching.